Welcome to this guide on predictive modeling for heart disease. In the next few minutes, you'll discover a streamlined workflow that takes you from raw medical data to a powerful prediction model. Watch as we transform patient records into actionable insights. We'll process key health indicators including age, gender, blood pressure readings, cholesterol measurements, and family history. Let's start by setting up your data and project. Simply click Upload Files and select your CSV file. The system automatically uses default sampling settings to ensure efficient processing. Your charts and data analysis will work smoothly with this sampled dataset. Choose which team members can access and work with this dataset. Create a new project. This is your workspace for developing the machine learning solution. Specify the type of problem you're solving, in our case, classification. Add team members who will collaborate on this project. After you create the project, you will have to select the datasets that will be used in this project. All experiments created in this project can use these datasets. Within your project, each team member can create their own experiments. Try different approaches and configurations. Work independently to find the optimal solution. This structured approach ensures organized collaboration while maintaining data security and project clarity. Navigate to the Dataset View page within the experiment. Here, you'll find a variety of charts and metrics already calculated and displayed in a clean, intuitive layout for your convenience. The total count of rows and columns in your dataset, along with the number of duplicate rows. A clear breakdown of how many rows have missing data for each column. An outlier chart to help you identify anomalies in your data. Exploratory data analysis, EDA, summaries. A correlation matrix showing relationships between different variables. This view provides a comprehensive snapshot of your dataset, enabling you to quickly assess its quality and characteristics. First, we'll review the data types of each column and update them if necessary. For the glucose column, we'll replace missing values with a mode, and then remove any rows with remaining missing data. Next, we'll identify columns with missing values and drop it. Using the outlier chart, we'll clean the dataset further by deleting rows where total cholesterol is greater than 600, or blood pressure, BP, exceeds 295. Since the dataset is highly imbalanced, with the risk of heart disease marked as true for only a small percentage of individuals, we'll use an oversampling method to balance the dataset, by increasing the rows with false cases to match the count of true cases. Next, we'll calculate feature scores and select the top 10 most important features. After that, we'll split the data into training and testing sets, with 80% for training and 20% for testing. Finally, we'll standardize the data using the min-max scaler to prepare it for modeling. Now, it's time to start training our model using different algorithms, to find the one with the best accuracy. Head over to the Training tab, where we'll create and manage our training sessions. Let's start with the k-nearest neighbors, KNN, algorithm. For each parameter, you'll notice commonly used values pre-filled for your convenience, making the process smoother. Feel free to modify these as needed and use the Quick Entry tool to efficiently input multiple values simultaneously. Once you've configured the parameters, click the Train Model button. Behind the scenes, Icandoml will automatically spin up a container and begin the training process. The best part? While one model is training, you can set up additional algorithms to maximize your productivity. As training progresses, the Started On column displays the start time. Once completed, the Completed On column will update with the finish time. And the model's accuracy score will appear in the accuracy column. For detailed results, click the View Result link. Here, you'll find the model's accuracy percentage, best parameters used, classification report, confusion matrix, and, where applicable, feature importance. Additionally, at the bottom of the training grid, you'll find a bar chart comparing the accuracy of each model. This visual representation makes it easy and empowering to see which model performs best at a glance. This information gives you a clear, detailed picture of each model's performance. Once your model is trained, making predictions becomes quick and straightforward. 3 methods to start predicting with your trained model are single record, multiple records, and API calls. You can manually enter a single record for prediction by filling in the required values in the provided input fields. Some fields may require numerical input, while others might include drop-downs for categorical values. Once you've entered the details, click Predict to run the inference. If any field contains invalid input, the system will highlight the problematic field and display an error message. Ensure all mandatory fields are filled with valid values before submitting. Once submitted, the system will return a prediction result based on your trained model. To predict multiple rows, you can use the Upload CSV function. Click on the Multiple Records tab, prepare your CSV file with the necessary feature columns, and click Choose File to select your file. Then, click Predict to start the batch inference. The system will process the data, generate predictions, and automatically download a CSV file containing the results. To ensure a smooth process, make sure your dataset includes all required columns, maintains correct data types such as numerical or categorical, and avoids missing values unless the model is designed to handle them. After the inference is complete, the system provides detailed feedback. A green success box will confirm that all records were processed successfully, and predictions for each record will be displayed. If there are errors, a red warning box will appear with details, such as the number of rows in the data, the number of rows with no issues, the number of rows with issues, and a summary of the row-level problems. Issues might include missing features, incorrect data types, or extra features being sent for inference. The system will display affected rows along with their error details. Common row-level issues include categories not present in the training data, missing values in a required column, or values outside the range used during training. The system will still proceed with predictions even if some data has issues, however, the accuracy of the results may be affected. You have the option to correct the dataset and rerun the prediction. You can also make an API call to the prediction endpoint. Pass the training and in the data for prediction, and the API will return the prediction outcome. Contact us to learn more.